Alright, so this is the remediation for 7.1/2, but part B, where we have all the application questions. And while I will be giving you some formulas, you have to know how to use the formulas, so that's the tricky part. So here, for instance, this is the general representation for exponential growth and decay, and the A value, the number that's in front of your growth rate, this is the original amount or the starting value. That's why they typically use an A for that, but sometimes it's another variable. The idea is whatever coefficient is in front of that factor, that's your original amount. The positive and negative changes depending on whether you're adding or subtracting or growing or decaying, so we got to watch that in the question. The R represents the rate, and you have to write it as a decimal. So keep that in mind. And then T, no one was shocked to hear that T represents time. The unit of time changes on each question. Sometimes, like bacteria, grows every hour, days, it depends. You gotta just watch your units on your problem. So this first question here, they want me to set up the formula, and then they want me to use the formula to predict a future value. So the original amount is given to you, 946,000 people, and then it says it decreases 7%. So what that means for me is that our R is 7%, you got to write it as 0.07, but because it's decreasing, we have to use a subtraction sign in the formula because it's going to be less than 100%. So 946 goes in front, goes in front. In the parenthesis, you're going to have 1 and then minus R, which is 0.07. If you simplify that to 0.93, that's totally fine. And then to the T power for now is fine, but what you're going to do here is they want the population after 6 years, so you're going to plug in 6 into the home screen. So I don't have a calculator handy right now, but you guys are going to need to go in your home screen of your calculator and you're going to type 946,000 and then 1 minus 0.07 and then up to the 6th power using that caret key. And with this being a population question, you should be, just rounding to the nearest whole person rather than a fraction of a person. That seems awful. So, the question that usually hangs kids up here on number 3 is they're not sure what they're doing, but they are pretty sure they're going to set it up. Now, they used A instead of Y. This is classic science. They're always messing with my variables. But this is the original amount of the bacteria, so we're going to put that number in front here. And then this time the bacteria is growing by 2.5%. So with it growing, you're going to use a plus sign. But watch the decimal. This is 0.025. I had a lot of kids, when we tested this, put 0.25, which is 25%. And that's why they got it wrong. Now this time, we don't have time. So I'm going to call it X, or you can call it T, whatever you want. And what you're going to have to do for me is, when does the population reach 1,000? You're going to need to go to your table this time after plugging this into Y1. And then when you go to your table, you're going to watch your table, and you might have to scroll around for a little bit, but eventually you're going to see this value over here hit about 1,000. And then you're going to tell me, when does that occur? How many, what is this measuring in? Minutes. How many minutes later? And you can say answers like between 5 and 6 minutes. That's fine for Algebra 2. When you move on to your next math class, they're going to make you be more exact about it. All right, a couple more formulas here. Remember, PERT, I'm not going to do these problems for you because I want you to try them, but PERT is special when they say the stuff is growing continuously. So P this time represents the initial amount. E is just a number on your calculator. This is like E the number. And then R is still going to be a rate as a decimal. So like here, your R value is 0.025 again. And then T, of course, is time. And that's up in the exponent. So E is an irrational number, 2.718, blah, 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 blah. It's on your calculator. There's 2 places it's on the calculator, and we've covered that in our lesson. Now, the compounding formula has a lot going on. Because you're collecting interest more than once a year, they've added a factor of n to your formula. So like right here, you're dividing by n, and then up in the exponent, instead of just T up here, you have the factor of n as well. So n is the number of compoundings per year. Everything else is the same from the previous formula, but n is a different idea. Number of compoundings per year, and I say per year because our questions are usually per year, But like for instance here it says it's compounding monthly, so that means your n would be 12. You'd have 12 times you'd collect interest in that problem per year. All right, and I don't think I'm going to do any more of these questions for you, because otherwise I'm doing like the whole worksheet. But please do come in and get help, and please do come in and use my calculator. Good luck.